Alright, this is how you do a Simony in the sound chapter, or waves. So here the equations we're going to be using today. I is equal to power over 4r pi squared. And the reason we're doing this, get my pen back. So the power is the power of the sound that's in the sound wave. Intensity is how much that sound is crossing a surface area, and r is the distance from the sound. Since sound actually goes in a circular motion like a sphere, here's the source of the sound, and this is going to be r, which is the radius of the sphere. And so how much power of the sound wave, intensity of the sound wave, depends on this power divided by 4 pi r squared, which is the surface area of where we're located. At this far distances, this is actually more of a plane than a arc or surface of the sphere, but you get the idea. So we're going to be using this equation, and also with this equation, decibels is a very easy calculation. You take the logarithm of intensity divided by 1 times 10 to the minus 12. This is the limit of how much we can hear the intensity. When you take the logarithm of that times 10, you get the decibel. And these are the two equations we'll be working on in assignment E. Now, with this, we got somebody that whispers a secret with a power output. So power is 2.05 times 10 to the minus 10. And here's the sound intensity that we're looking at. So this is I. I'm going to figure out what R is. So we're looking for R. Intensity is 4.1 times 10 to the minus 10 watts per meter squared. And so we're looking for distance. So the equation again is intensity equal power divided by 4 pi r squared. Now with this, we're looking for R. When you're solving this, please range the variables first before putting numbers in. I'm going to divide both sides by p. Divide both sides by p, so it'll be I over p is equal to 1 over 4 pi r squared, and that would be simple to use, but we're looking for r. So let's redo this, saying multiply both sides by 4 pi r squared. So 4 pi r squared times I is equal to p. And then r squared is equal to p times 4 pi times I. Then r is actually taking the square root of this mess, p over 4 pi times I. So power is 2.05 times 10 to the minus 10 4 pi times intensity, let's go back, 4.1 times 10 to the minus 10. And that's going to equal R. So when you do the calculations, folks, this number and this number is a scientific notation. Unless you're using the exponent key, put these numbers inside parentheses. The biggest mistake I'm seeing on the exams is that you guys are not dealing well with this type of calculation. So 2.05 raised to the minus 10th divided by, let's go ahead and put parentheses, times 4 times shift pi. Now remember, we're not squaring pi. We're going to be taking the square root of the whole this thing. So this is r squared. So we're going to take that. Let's make sure we get this correct. And then times 4.1 raised to the negative 10th. And when I do the calculation, and I take the square root of my answer, R is going to be 0.19947, so let's go ahead and make this 0.20 meters, or the person is 20 centimeters away from the person. So that is R. This is how you calculate that mess. We want to get R by itself, R squared, so it'll be P over 4 pi I. Take the square root of both sides to get rid of the square, and that's how we figure out the distance away from the source of the sound. I hope all this makes sense. So the next question is, what is the decibel level of the whispering? So intensity, again, was 4.1 times 10 to the minus 10. Again, we're dividing that by the limit of sound that we can hear, the limit of lowest level of intensity, and I'm going to flip back to 1 times 10 to the minus 12. And when we take that, we're going to take the logarithm of this and multiply it by 10. This is going to be my decibel. So in the calculator, parentheses 4.1 raised to the negative 10th, close parentheses, divided by 1 times 10 to the raised to the negative 12. And then you're going to take the logarithm of that number, which is going, and so you're going to have 10 times 2.61, or the decibel answer is going to be 26 decibels, which is a fairly low number. So that is the sound threshold. 1 point times 10 to the minus 12 divided into this guy, which is the intensity of whispering. Take the logarithm of the number, and then you multiply it by 10, and you get 26. And that's the answer. If you have any questions over assignment E, please email me or talk to me during Zoom. Thank you.